Today let us continue with chapter 9, application of trigonometric ratio. We'll see question number 12. Here we have a vertical tower which stands on a horizontal plane and surmounted by a vertical flagstaff. Let us try to form the drawing first. We have a vertical tower, so we can take the tower to be this one. Okay, then they say it stands on horizontal plane, so that means the plane we can state is straight like that. Then surmounted means at the top. So at the top of this tower there is another stick which is used as flagstaff. Then they say 30 meter away from the tower. So this is the tower. If we walk 30 meter from here, okay, we walk 30 meter from the tower, then what happened? If we stand at one point, angle of elevation mean when we look up at the top of the flagstaff. So remember, this is the flagstaff, so the top will be this one. When we look at the top of the flagstaff, we get the angle here is equal to 60 degree. Then when we look at the bottom of the flagstaff, that means here we find the angle is 45 degree from same point. Okay, from same point, if we look at the top, angle is 60. If we look at the bottom, the angle is 45 degree. So then we have to find the height of the flagstaff, that means this one, and the height of the tower, this one. So we give a name, then from there we can find out. So you see here, refer to this angle, we have the base. Then this one, they are for angle perpendicular. So we have base, we want P. That means we can use the tan theta, because we know tan theta equal P by B. So I hope the diagram is clear. Okay, we have a vertical tower, that means this one. At the top of that, we have the flagstaff. Then from the tower, we walk 30 meter away. We look up to the flagstaff. When we look at the top, the angle is 60 degree. When we look at the bottom, the angle is 45 degree. And remember, this is not 60, okay? Because 60, we always have to refer to the horizontal plane. So now we are using trigonometric, so we have to use right triangle. So we will take this one, always refer to the right. We cannot use this small triangle, but we always have to refer to the right triangle. So let's solve it now. So we can name them now as P, Q, R, S. Okay, draw properly. So you can write the given angle of elevation is given to be 45 degree and 60 degree. Then the distance from the foot of the tower here, RS in this figure, it is equal to 30 m. We want to find the height of flagstaff. We consider it to be PQ. Then the height of tower, we consider it to be QR. Then let us start first with this small triangle QRS. We know base, we want perpendicular, so we can use tan. Then in this small triangle, which theta we will use? We will use 45 degree. Okay, so we will use tan 45 degree. Then from the definition of tan theta, we know that it is P by B. So our P here is QR, our B is RS. So we can write it that way, okay? Tan 45 equal QR by RS. Tan 45 from the table, we know it is 1. QR we still have to find. RS we already get 30. So you can cross multiply, then we will get QR is equal to 30. Then next we need to find another one. So we will use this big one, PRS. Now we will use 60 degree. So again, tan 60 will be perpendicular. So it will be PR by RS. RS we know 30, PR we still have to find. Okay, tan 60 from the table we know it is root 3. PR we don't know, RS we know 30. So we want PR, you cross multiply. It will be 30 root 3. The value of root 3 we know 1.73. But if you see from here, we don't want PR, we want only PQ. So if you look from the figure, PR, we can break it as PQ plus QR. So we can do that. Okay, PQ we still have to find. QR we already have from here, 30. So this is plus. If you take the side, become minus. So here you multiply. So if you minus, you'll find that PQ equal 21.9. 30 has no decimal, so minus it only from 51. So we get the height of tower is 30 meter and the height of the flagstaff is 21.9 meter. We will move on to question number 13. We have a tower whose height is 50 meter. So we imagine there is a tower there. The height of this tower already given to be 50 meter. Then what happened? Its shadow is 8 meter shorter when the sun altitude is 45 than when it is 30 degree. So the shadow, it will come this way. Okay. So sun altitude mean the angle. So if the angle is 45, as to say, that means the angle of elevation of the sun, if it is 45, the shadow reach only up to here. Then when the angle is 30 degree, the shadow reach up to here. Okay, when it's 45, the shadow is from here to here. Then when it is 30 degree, the shadow increasing up to this here. Then what they say, the shadow is shorter by x. So that means here you can see, okay, this is the longer one, this is a shorter. The difference between these two is x. So now we have to find the value of x. Okay, so remember we are doing with trigonometry. So try your best to get the frame of a right triangle. So here we have two angles. We want to find this side. This one is perpendicular, this one is base because nearer to angle. So that means again here P by B, it is tan. We can again use tan theta. We have two triangles. So remember we have to use always the right triangle. Okay, we do have this another triangle here, but we cannot use it because we always have to refer to 90 degrees since it is trigonometry. So after drawing the shape properly, now we can start. Let's start first in triangle ABC. Okay, since we want to find the base, that means we'll apply tan. So here we will use tan 45. Tan 45, we know the definition is perpendicular by base. In this case, it will be AB by BC. Okay, those. Then tan 45, we know from table 1. AB already given 50. We have to find BC. Cross multiply. BC is 50. Then next we will use ABD. So those in ABD, what angle we have? 30. So again we will use tan. It will be AB by BD. So those. Then tan 30 we know 1 by root 3. AB is given 50. BD we don't know, but remember we want to find x. So this BD, if you look from the figure, we can break it into BC plus CD. Then BC we get from here 50. Then BD, if you look from the figure, CD we get x. Okay, those. So here we cross multiply root 3 into 50, BC plus x there. Okay, so BC we already know 50, we can replace. Root 3 we know the value 1.73. So you multiply 50, 1.73, you get this one. We want only x. So this is plus, take that side, become minus. Here separated by plus, so we have to shift the other side, become minus. So 50 has no decimal, minus from 86. So we get that x is equal to 36.50 meter. Then we will proceed on to number 14. Here we have the angle of elevation of the top of tower from a point A on the ground. So again we have a tower. Then if we walk at some distance away from the meter, okay, we are standing at this point here. When they don't give name, then we can give whatever we like. But here they give the name of that point is A. Okay, see we have a tower. Okay, then from a point A, angle of elevation mean when we look up to the tower, we find that the angle is 30 degree. Then what else we have? on moving a distance of 20 meter towards the foot of the tower. So that means from this point A, we are moving nearer to the tower now. We have a second point. Okay, the distance from here to here, it's given to be 20 meter. They say towards mean we are going to thing. Okay, nearer to the tower. It is 20. We reach a second point B. Then from there also we look up to the tower. We find that angle is 60. So when we reach this point here, we look up again. Then that angle here now, it find to be 60 degree. So let's see what we have to find. We have to find the height of the tower and the distance of the tower from the point A. So this is the tower. The height will be this one. The distance will be this one. So here again we see the relation between perpendicular and base. So that means we can use tan in these two triangles. I hope the diagram is clear. Okay, we have a tower. Then at some point from the tower, at some distance, we have point A. From point A, we look up, angle is 30. Then when we move nearer to the tower, 20 meter nearer to the tower, we have another point B. When we look up there to the same point, we have the angle is 60. So we'll have to find the height of the tower and the distance of A from the tower. So let's do it. So after drawing it properly, so here we have the relation as to say perpendicular and base. So we can use tan only. Okay. So we will start in triangle DCB. So it will be tan 60 here. It will be DC by BC. So there. So tan 60 we know √3. These two we don't know them. Let it be there. So let's just cross multiply so that we can use it in the next triangle. So BC will be DC by √3. So we cannot do anything, leave it there. Then next we take the second triangle. Remember, we always have to refer the right triangle, okay? We cannot take this one. We always have to take DCA. Only then we can apply trigonometry. Here we have the angle 30. So that means tan 30, again it will be DC by CA. And again CA, we can break it as CB plus BA. Then BA, we already have equal to 20. Okay, then tan 30 from the table we know 1 by √3. Then this one I told you we can break it. Then now we cross multiply here. Then here BC. Okay, we don't know, let it be there. AB we know from here 20. So here we have DC, BC. So let's try to replace the same one we have from here. BC equal DC by √3. So in place of BC, we can put with DC √3. So now DC, DC, we can bring them one side. This is plus, take that side become minus. So we have fraction we can find. No need to find LCM. You can rationalize or you can find LCM also, no problem. Those. Here we have √3 and 1, √3. So √3 into √3 will be 3 DC. Okay, those. So this one we can cross multiply this side, 20 √3. DC minus this one, because here √3 into √3, 3. So 3 DC minus 1 DC, it will be 2 DC. Okay, so when we get 2 DC, because we want only DC, that 2 you can divide here. So √3 we know the value is 1.73. So there 2 divide 20, you have 10. 10 into 1.73 will be 17.30. So we get the value of DC is equal to 17.30. So let's see what is DC. DC is the height of the tower. Next we want AC. So AC we know it is BC plus AB. Okay, so we have to find BC here. We know DC. We can use this one for easy calculation. Okay, from here, because we have 2 DC, then here we can cancel, we can take 10 √3. You can replace either with this one or easier calculation this one. Okay, we put it here in place of DC, we can put 10 √3. So √3 cancel, BC will be equal to 10. So we get that mean we want to find the distance of A. So here we get 10, here 20. So 10 plus 20 will be 30. So we get the height of the tower, then the distance of A from the tower is 30.